Today we are going to focus on OTV, which is another Nexus feature. With this, all the unique topics of Nexus is getting over. After this, we are going to see those things that are well known to us in routing world. We have like Ether channel, trunk port, and so on in Nexus. So OTV is another special unique feature that is available only in Nexus, but recently it is also now supported in ASR 7000 series, I believe. Not on every ASR, just one. So OTV, overlay transport virtualization. Overlay transport virtualization, what it is? What is special in OTV? Before that, it is supported only on Nexus 7000 series. In Nexus family, not supported in 9000, not supported in 5000, only on 7000 series. Now, what is OTV then? Overlay transport overlay, which means there is another underlay. Overlay transport virtualization. Then what is over and what is under? Under is layer 3. Over is layer 2. This is what OTV is. Layer 2 on top of layer 3. You can also call it as MAC in IP. MAC in IP. Usually IP will be in MAC. Usually it is layer 3 over layer 2. Means under will be layer 2. Layer 3 will travel on top of it. That's what normal networking is. Every hop, layer 3 travels on top of layer 2 between routers. But this is opposite. Layer 2 is traveling on top of layer 3. Layer 2 means what? MAC. MAC travels on IP. Usually every hop the MAC address will change in normal routing, but the IP address will be same end to end. But in this case here, MAC address is going to be same end to end. The upper layer MAC address only will change. The inner layer will not change. I'm not going deep into that now. For example, I'm using these words like MAC address end to end will not change. That is also true. But this is done because you got a underlay that provides this overlay, and the underlay is made of layer 3. That layer 3 has got another layer 2. Their MAC address will keep changing. I think you did not understand it. No, it is confusing. Let me explain it clearly. We got a data center, green. We got another data center, red. Geographically in two different locations. Now we got big internet in the middle, which should be in blue color. two data centers connected to internet service provider. Let me call this as DC1, DC2. Between these two data center, if I need a layer 2 connection, between these two data center, if I need a layer 2 connection, what does it mean? Inside I have some devices in VLAN 10, some devices in VLAN 20. And I want this VLAN 10 and that VLAN 20 to communicate to the remote VLAN 10 and remote VLAN 20, remote data center. I want this computer to communicate to this computer as if they are in same local area network. Usually what we do is we take a very costly setup, costly solution to solve this, which we call as VPLS. We need to buy a VPLS service, virtual private LAN service, or VP wired service, or any transport over MPLS. But these are all very costly, very, very costly. If you have any one of this tunnel, layer 2 tunnel provided by the service provider, this is possible. A can talk to B. Between A and B, no routing, only switching. Is it true? Yes, as per the customer's packet, as per the data center's traffic, no routing, only switching. But you know, this provider edge and this provider edge has got a routing to provide this layer 2 support. So for the packet to encapsulate and tunnel between this PE1 and PE2, there is both layer 2 and layer 3 routing and switching involved. So we are not going to focus on that ISP part. If you don't focus on ISP part, then you can very well say between A and B there is only switching, no routing. How? Because it's a layer 2 tunnel now. It's a layer 2 tunnel between these two sites. Anything that goes inside here will go out and get delivered here. No routing, just layer 2 switching. MAC address will be learned through the tunnel when an ARP request goes. And the next MAC address of B, the B's MAC address will be seen as the next MAC address in A. When A generates the traffic, what will be the destination MAC address? It will be B's MAC address. That itself proves that there is no routing in the middle. If you have routers in the middle, then router's gateway address will be the layer 2 MAC address, destination MAC address. But here there is no routing. A and B communicates as if they are in same local area network. Likewise, C and D communicates. E and F communicates as if they are same local area network. E, F, G, H. Even though they are in two different locations, they communicate as if they are in same LAN. It is because the internet is not seen. How? Because it is covered by the overlay called VPLS or ATM or VPWS. So there is an overlay which is carrying the layer 2 traffic. See, ATOM, any transport over any transport, it can be MAC address, it can be IPv6, any transport over MPLS. So it can carry very well a layer 2 traffic. Likewise, virtual private LAN service, VPLS. Virtual private wired service. Wired service is point-to-point. LAN service, VPLS, is multi-point. Using encapsulation MPLS or L2TP, you can do this. Fine. Our area of study is not MPLS or VPLS or ATM, ATOM or APWS. I'm just giving you a solution. If you want to communicate between A and B, just like a layer 2 switching, not the routing, these are the options we have. What's the problem with this option? Costly. Every month we need to subscribe for this WAN connection, for this VPLS or VPWS or ATOM connection. Costly. So what is the cheaper solution? Cheaper solution is OTV. How OTV is cheaper? You see, layer 2 VPNs are costly. You buy a layer 3 VPN. We buy layer 3 VPN between these two sites. There's a layer 3 tunnel. With the help of the layer 3 tunnel, you will be able to ping between these two routers. So there's a public IP address given here, let's say 2.2.2.2 here 11.11.11.11. Let me call it as DC1A, B. A and B are customer edge. We got a layer 3 tunnel, layer 3 reachability, simple WAN connection between these two sites. Compared to layer 2 VPN, this is cheaper. Any device can allow you to have a layer 3 VPN, but for VPLS, you need special ASR devices. So definitely layer 3 VPNs are always costly. Layer 2 VPNs are always costly. Layer 3 is cheaper. Layer 3 VPN is cheaper. So with the help of layer 3 VPN, you got reachability between these two sites. Now you buy the Nexus DC1 Nexus 7K1. Connect here. Buy another DC2 Nexus 7K1. Connect here. Provide a public IP address. Meaning, make sure you are pinging between this N7K1 between the sites. Make sure there is a reachability between this 7K1 and this 7K1. If you want, you may replace this router with Nexus. It's your wish. We need reachability between 7K over this layer 3 VPN. So what you can do is you can simply replace it with this one. It's okay to have a router if you want. If there will be any genuine reason, you can have router, but if you don't, you can replace the 7K and give the public IP address to this WAN interface. Now Nexus 7000 series, both are pingable. I was telling you this Nexus 7000, by using the reachability between the sites, it can negotiate a tunnel now. It can negotiate a tunnel between these two. And this tunnel can carry layer 2 traffic. See, for you to have this layer 2 tunnel, this layer 3 connectivity was needed. The layer 2 connectivity is needed. For this layer 2 connectivity, every hop there is a MAC going to change. That's the upper layer. That's not our story here. We are not going to focus on how ISP is taking our traffic. MPLS is not our topic today. It's OTV. So what I'm saying is, layer 2 travels on top of this tunnel. This tunnel is on top of layer 3. Underlay is layer 3. Tunnel is layer 2. Over this tunnel, you can send ARP requests, you can learn the MAC address of the remote site. So when a packet goes out from here, the source address is A. That's the MAC address. Destination address is B. It is not a provider edge MAC address. It's a final device MAC address. It goes through the tunnel, and this 7K1 knows where is B and it delivers the packet here. MAC in IP. Layer 2 over layer 3 is what OTV, overlay transport virtualization. But this feature OTV is available only on 7000 series. See, still you need layer 3 VPN to provide reachability between these two data centers. Next, this tunnel that we have, the OTV tunnel, this is going to be a trunk link. That can carry multiple VLAN traffic. So VLAN 10 and VLAN 20 can travel through this trunk link. In layer 2, when you configure a trunk link, how many VLANs are allowed? All the VLANs that you have. By default, all VLANs are permitted on the trunk link. Whereas this trunk on OTV, even though you have configured it as trunk, you need to specify very clearly which VLANs that we want the traffic to pass through. You may have many VLANs in your data center 1, but you wish only VLAN 10 and 20 to communicate to the remote data center. So what is needed is you need to just go to the trunk OTV link and say, I'm expecting only VLAN 10 and 20 to be extended to data center 2. So that is good that by default no VLANs are allowed on this trunk link unless you specify. You need to go to this OTV trunk link and you need to specify that I want to allow VLAN 10, VLAN 20. Not only that, you also need to mention what type of traffic that can pass through this OTV tunnel. If it is VLAN 10, in VLAN 10, what type of traffic? Unicast? Multicast? Broadcast? Which one? Or all of them? We have to mention what all type of traffic that can pass through this OTV tunnel in VLAN 10 and VLAN 20. Yeah. So the OTV tunnel is negotiated between the customer edge. That is the advantage. The tunnel is not between PE to PE. The tunnel is between DC1 to DC2. Even if you have 10 service providers in the middle, you don't need to worry. As long as I have reachability between Afghanistan and Libya, Afghanistan router pinging Libya router. How many ISPs are there? Etisalat, Orido, and many more. That doesn't matter. As long as I have the layer 3 VPN, layer 3 reachability between these two data center 7,000 cities, I can easily form this tunnel without requesting any ISPs. Why ISP need to do anything for me here when Nexus 7000 can provide a layer 2 tunnel? We don't need to depend on ISP for a layer 2 service. You can have your own service, your own layer 2 service. We are not dependent on ISP when we have this Nexus 7000 for layer 2 services. Right, so that's the only disadvantage also. You need layer, you need Nexus 7000 series to do this. Not any other. That's one disadvantage. Alright, so advantage is it is cheaper. We no need to depend on service provider is another advantage. No VPLS, no ATOM, no VPWS. And we have our own layer 2 tunnel between the edge to edge. Data center 1 edge to data center 2 edge. Now let us draw some bigger picture. Now we got data center 1, data center 2, data center 3, and we got ISP, we got our Nexus 7000, we got multiple sites here, not just two, we got multiple sites. And we got layer 3 VPN already, as we discussed. And we say we also discussed saying that between the 7K you have OTV tunnel, which is a trunk link. It's a trunk link that can carry multiple VLAN traffic. It's a trunk link. OTV tunnel. It's a trunk link. Let's say we got a switch in which I got VLAN 10 members, VLAN 20 member. And this will be DC1, DC2, 3. We got 3 data center. We got layer 3 VPN. On top of this, we are going to have OTV, a layer 2 tunnel that can carry layer 2 traffic over this layer 3. Now what this link will be? This is also going to be trunk link because VLAN 10, VLAN 20, VLAN 10, VLAN 20, trunk link, VLAN 20, trunk. So this is normal switch that gives multiple VLAN traffic to 7000 series, and on the OTV tunnel we have allowed this VLAN on this trunk link, VLAN 10, VLAN 20. We have allowed. So the tunnel is ready to carry, but who will give the MAC address of the remote site? You see, if this computer MAC address is AAA, if AAA wants to communicate to data center 2 VLAN 20 red PC, not possible. It is 2 different VLAN. Sorry. So if AA wants to talk to VLAN 10 in data center 2, whose MAC address is CCC, the switch should know that CCC is connected in data center 2. Data center 1 nexus should know that CCC DDD is connected in data center 2, EEFFF is connected in data center 3. For this distribution of MAC address, we need a protocol. We need a protocol that will run over the tunnel, learn the MAC address of this guy, give it to these guys. Learn the MAC address of this guy and give it to these guys. Learn the MAC address of this data center and give it to these 2 data centers. So we need a protocol so that the MAC address of the remote sites can be learned on the 7000 series nexus. For that, this protocol, intermediate system to intermediate system, is used. So when you enable OTV, what happens is this routing protocol ISIS also gets enabled and form adjacency with the remote 7000 nexus where the OTV is enabled. ISIS takes care of the distribution of MAC addresses between these sites, intermediate system to intermediate system. ISIS. So do we need to know ISIS for this OTV? Not necessary. You just enable OTV. Now how OTV is enabled? OTV is one of a kind of tunnel interface. If you have done GRE, you might have created interface tunnel 0, tunnel mode GRE. You might have said that. If you want to do 64 tunnel, you might have said interface tunnel 0, tunnel mode, IPv6 64 tunnel mode. So we use the tunnel interface, right, to form tunnel. Likewise, here there is a tunnel interface, a special tunnel interface called OTV interface you need to create on all these three devices. OTV device. OTV interface. Actually, the command is OTV interface OTV1. Interface OTV1. Interface OTV1. We need to go to this interface and say use this physical interface. Same like what you do for GRE tunnel. Have you done GRE? Yeah. Alright. So where we will say tunnel source, tunnel destination. Likewise, here also we'll be saying what tunnel source to use. Optionally, you can say tunnel destination so that when a new MAC address is learned, it will be sent as a unicast to all the tunnel destination. Or you can enable multicasting and provide a common multicast address so that using multicast they will flood the information to the remote site members. If you are doing unicast, then we need to define one of the site 7000 series as adjacency server. If I'll make this as the adjacency server, if DDD wants to know about EEE, it will go and request the adjacency server. Hello adjacency server, do you know anything about EEE? And the adjacency server will flood to all other asking who is EEE? And this will answer, I know EEE, take this. Then this will distribute, this will give it to this 7K. And then the ping happens. That's the unicast. You need an adjacency server, kind of hub and spoke. All the request goes to the hub. If you remember, the DMVPN hub will take care of that distribution of spokes router information using NHRP table, similar to that. But the problem with this unicast is, if you have more sites, then you need to configure all the sites for which there will be one adjacency. So it's not scalable. That's the problem with unicast. Multicast, you don't need to worry. They use ISIS and immediately flood to all other sites where the multicast address is same. See, ISPs do support multicasting. You don't need to request them. They do support multicasting. But it is good to request also once, to make sure that they have multicast support on this MPLS layer 3 VPN. If they have the support for you, if they are ready to provide this multicast support for you, then we can use multicast. And ISIS will use this multicast address to distribute the MAC table. So whatever the MAC address that are learned here in this N7K will be reflected to these with the help of ISIS, and vice versa. All the switches will reflect it to other switches. That is how one data center will know the location of the remote device in different data center, so that there won't be flooding all the time. So what is OTV? overlay transport virtualization. Underlay is a layer 3 MPLS VPN or any layer 3 connectivity between the sites. So using that reachability between this 7000 series of all these sites, tunnel is negotiated, OTV tunnel. For that you need to create a OTV interface and map it to this physical interface. The tunnel destination can be Unicast by configuring an adjacency server, or it can be using multicast. ISIS takes responsibility of distribution of MAC table. So ISIS forms adjacency between the site devices. For this, you no need to enable ISIS or you no need to configure ISIS. You no need to know about ISIS. When you enable OTV, ISIS gets enabled instantly. So OTV is the cheaper solution for anyone who has got Nexus 7000 series to provide a layer 2 communication between sites. If we don't have Nexus and if we are ready to do subscription every month and get a VPLS or any transport over MPLS, it's okay, but it's going to be costly. And also we learned that this VPN is going to be, this OTV tunnel is going to be a trunk link. So the difference between the normal trunk link and this trunk link is the normal trunk link will allow all VLANs by default, but this trunk link, the OTV tunnel, allows only those VLANs that we add to the OTV interface. It will allow only those traffic that you mentioned. If you say multicast traffics are not allowed through the tunnel. So we have to specify what type of traffic, unicast or multicast or broadcast. What do you want the tunnel to carry? The layer 2 broadcast, the layer 2 multicast, the layer 2 unicast. Right, that's all the overall view of OTV. Do you have any question?
For this one, for the DC1, for the 7K to be act as adjacency server, for that we need to enable some commands.
Yeah, there's some special commands there, so that this will act as a hub. That is the other way of calling adjacency server. We'll see those things in the configuration part.
Can you give some idea of ISIS?
Alright, ISIS is a very good routing protocol, which I like the most. But why it didn't gain popularity is, I will say, politics. The politics of networking companies. See, ISIS is going to be in future in a very big level, and they do not want to expose it right in the beginning. So they introduced OSPF and they were praising OSPF and say OSPF easy, boop, boop, boop. But OSPF is like an ambassador car. It cannot fly. So we were driving this ambassador car for this many years. It is so easy, just simply sit and drive. And we were comfortable with OTV SPF, because it's easy, like driving an ambassador car. But ISIS can be an ambassador car, can be a flying machine, can be a boat. That is ISIS. So this all capable multi-personality protocol was not thought properly because they want this protocol to be for future. They're keeping it for future, and that future has come already. This ISIS, as I said, if you attach one wing, it will start flying. If you will attach some flat thing under the tire, it will become a boat. But under the ambassador car, if you put one flat thing, it will break. If you put one wing, it will not fly because it's an ambassador car. What I mean is OSPF cannot do all the additional extra things that ISIS can do. OSPF is a very good layer 3 routing protocol, period. That's all. Whereas ISIS is not only a very good layer 3 routing layer 3 routing protocol, it can be a layer 2 routing protocol. What? Yes, layer 2 routing protocol. I said correct. It can route the packet based on any ID, not only MAC address, not only IP address. You give any ID. Once there was a feature called fabric path in Nexus. Now it's no more. So using just the fabric ID, the ISIS can route the packets. Fabric ID. It's neither MAC address nor IP address. Now we get something called segment routing, like MPLS label. Using that, ISIS can route the packet. ISIS is such a nice extendable protocol, routing protocol. It can route packet with the help of IP address, with the help of MAC address. You give any ID, it will name it. This is. You give any tag ID, give any name. It will use that number to communicate, to identify. It's extendable routing protocol. That is why it is used here in OTV. That's why it is used in fabric path, segment routing, IPv6. ISIS is a very good protocol, not only for service provider, even for enterprise. So ISIS actually was not designed early to support IP. It was for a network called CLNS, connectionless network service. But later that CLNS disappeared and IP came, IP networks came. So I modified, that's what I was telling you, the ISIS can be extended to support anything. And they did some extension, it started understanding IPv4 address, the 32-bit address. And again extended, it started understanding IPv6 address. Again extended, it started understanding segment routing, segment IDs. Again it is extended, now it is supporting OTV IDs, OTV IDs that is used inside OTV, fabric path ID. So it's a special routing protocol. It need to be learned separately as a separate routing protocol, which we should not confuse here. There is no need for knowing ISIS in data center world, but if you are more interested, we will have a separate day for ISIS. It's a very nice routing protocol. We had a lot of videos on ISIS in our old channel, which is stolen by some very good people in the internet. All thousands of videos have gone. All glory to them. Fine, otherwise I would have given some links for you from my channel. by this time. Anyway, I'll call you for another ISIS batch when I teach for some other batch ISIS. I'll put you in that batch so that you can learn ISIS. Any other question?